So, welcome to another brief Black Ops webinar. These are short things where we talk about stuff that's on our mind. So far, within this, we've got Alan and I. And Alan and I are going to have a quick chat about how we make our test results. That's to talk about. So, I think the most obvious set of results to make pictures from is performance testing. That's the easy one. You look at responses. A nice, easy graph where you go from when you started to when you ended. And often you're measuring response rates on that, and you can say, well, I got a high response, or it went very slow when it went up high, or it went very fast when it goes down low. But more commonly, you see some kind of spread. All of that data has to be gathered. So you've got a bunch of tools doing the sending out of various different things, and then you gather it back in, and then you look at it and go, I hate Excel for drawing graphs. And I typically use data graph for doing that. Data graph is lovely, but I've started to use something called Raw. Have you seen Raw? Did I show you Raw?
Can't remember. You might have done. I mean, normally if I'm doing performance testing, I'll use the Raw graphs and things, but you don't really get that with so I'll have to remember the names of performance test tools. Hang on a sec.
So I don't use the inbuilt tools because the performance tool I tend to use is JMeter. JMeter's, so it all comes out and goes into data graph for me. But I'm wondering about using Raw. Raw is an online service which actually isn't online. It just installs effectively a JavaScript application in a page, and you play with the data there. Anyway, tools aside, for me the key graph for that is a scatter graph. Generally because you're not looking at the connections between dots over time, you're looking at the way something is distributed over time. So drawing lines between dots just makes it noisier. So a scatter graph shows you where those points are. It shows you how widely they spread. And if you have dots, what you're seeing is at an instant in time, or over some period of time, you've got a range of responses. And if they're evenly spread across a range, and that tells you one thing, tells you perhaps that it's random. Often you find they're clustered. So you get a few that are very slow and quite a lot that are faster. And that will tell you something about how things are coming back. Sometimes you find this. Maybe you've got a cache involved in your test. So for performance testing, I tend to use a scatter graph, and I think they're lovely things to use. And I use data graph to draw my scatter graphs. How about you?
So when I'm using JMeter, I generally stick with the inbuilt graphs. I haven't experimented with Gatling enough, which is a Scala one, to know what it does for its graphing. But when I was thinking about making test results visible, I wasn't even thinking about performance testing. I had in my head, how do we make the coverage that we have visible?
Oh, what you mean?
Yeah, so any test that we're doing,
tell me more.
I'm thinking in terms of graphs. So I'll use GraphViz to show the paths through the application that we've taken, or mind maps to show something is having coverage, or just hand-drawn diagrams. So my thought process was slightly different.
Yes, it was. Yes, it was. I guess we've kind of got there's something which sits in my mind as halfway between those two, which is a grid. So if you've got, let's say, 2 or more variables that you're messing about with, and you want to see how those variables interact with something with a third variable, all that data lends itself to being dropped into a grid very easily.
Yep.
And if you, let's say you have a grid of variable 1 versus variable 2, and each cell on the grid is colored depending on variable 3, then you get something that we all recognize as a heat map. So something that is a large number might be red, a low number might be blue, and all points in between. And I suppose that there's a kind of paradigmatic example of that one for me is gone out of my head, not Brett Victor. Mike Bostock's looking at randomness algorithms, where what you hope comes back is something that is uniform, because when you randomly do something with no particular profiling randomness, you expect a uniform distribution. But if you've got a non-uniform distribution, if we with our eyes are able to perceive things in that scattering of on a heat map, then you've definitely got a problem in your randomness algorithm. So he's got a bunch of stuff that looks at randomness algorithms, and that gives some kind of understanding. No, that one doesn't give an understanding of coverage. I've got other things that give an understanding of coverage. I've disappeared at my own fundament. So, yeah, that's again, that's not an understanding of coverage. If you have two variables across two ranges, then you can look at the coverage across those two ranges. If you've got more than two variables, you can start to vary that as well and plot each set, and then you see an enormous amount of coverage in a small amount of time or so, by being able to cover each of two variables on a two-dimensional graph, and then any other variable becomes something that you adjust or modify. So you can see coverage, and you can see within a heat map what kind of coverage you got of your variables. Clearly, that's not code coverage. It's not requirements coverage. It's coverage of given ranges of testing.
Yep. In a given space of things, what have you hit? Which is, I quite like the mention of grids, right? Because then anyone can pretty much do a grid in a spreadsheet. You can put the things in, and I wonder how many people think about grids in terms of what underpins them. Because essentially, when you draw on a grid, you're representing a relationship, a particular type of relationship between those two things. So that relationship has to exist between everything in the grid. And then if you've got a relationship, you can model that in a whole bunch of other ways as well. You can model that relationship as a hierarchy or as a graph, and there's different ways of looking at that. So it comes down to how can we visualize different types of underlying models.
It's interesting when I get people to draw models when I'm working with them, sometimes they don't think of what the directions on the bit of paper mean. So they'll just draw something and they'll connect things together, and there is an implied meaning, typically because they'll start in the top left-hand corner and work their way right as we read, or work their way down the paper. So you find this expands down to the bottom left. But direction has meaning. And so you've got things like undos or changing your navigation that don't actually go backwards, they seem to go on. And that kind of problem, when I'm working with people, you can see their diagram's not going to work, or at least it's not going to work in a way that is, if you like, sustainable for a bit of paper, because you'll suddenly have an infinitely expanding thing rather than genuine loops on as you go round and round. Now, that may or may not be useful. But yeah, notation matters when you're making a picture, and direction is it's a sort of an underlying notation.
Well, it's interesting because sometimes when you're trying to visualize something in a custom way, it's hard because you're trying to represent everything on a single piece of paper, and that's not how visualizations work, because they're almost projections of part of an underlying model, and you have to exclude things from that projection and visualization to make it work.
My rule of thumb is I probably need to draw 2 or 3 pictures before I understand the picture that I'm trying to draw.
Yeah, that's why I like the notion of,
and whether that drawing using,
as long as people understand there's an underlying model and that is rich, then we can project it in different ways. Because like when you're doing a graph of performance testing, you've got all the data, but you're choosing to project a small subset for a specific purpose for the analysis of it.
Yeah, so the example previously was response time against the time that the particular response was taken. And you can get a different kind of graph if what you're looking at is not the time the response was measured, but the index of it, so what order it was in. Now, clearly, time and order are very related, but if you stack it by order, you get a different kind of information from if you stack it by time. Similarly, if you're response time, but the difference between this response time, the previous response time, you start to see interesting things. So, absolutely, your data is your data. That's the underlying thing. Then you've got a model in your head that you're making something from. And then from that, you're constructing a visualization. And that's why having easy visualization tools can make a big difference. Easy data munging tools as well with the visualization tools, because you have to go through that iteration before you start to see something that really leaps out. So, you know, one of my friends, you take your responses and you take whatever data you've got and you put it into bins to make a histogram. And depending on the width of your bin, so that's how big a group you're gathering individual bits into, you can see quite different histograms, sometimes very noisy, sometimes very blunt, and you have to pick and choose the right size. Once you've got a tool a bit like Datagraph where you can actually animate the number of bins you're putting into, then you can find the sweet spot to do that. Without that sweet spot, you're left doing pain in the hands, isn't it?
It's true. Most tools don't have that flexibility for giving additional attributes that are kind of secret attribute to grow the size of the column.
Well, one of the great joys with Excel is that you can just treat all the data and then graph other bits that you've treated from. You can't quite do that with Datagraph, but Datagraph gives you loads more access to how it's interpreting your data, which I think is really important, really useful to use. So that's my weapon of choice when I've got to visualize stuff. Is it's so very flexible. You do lots of different kinds of graphs with it.
Excellent. So that's a good recommendation to end the 10 minutes on.
There we are.